Morning all. Today I am going to explain the pentagonal problem in the position of planes. So we'll go to the question. A pentagonal lamina having edges 25 mm side is placed on one of its corners on HP such that the perpendicular bisector of the edge passing through the corner on which the lamina rest is inclined at 30 degree to HP and 45 degree to VP. Draw the top and front views of the lamina. So here it's a problem on pentagonal plane. It's having edges of 25 mm sides and which is resting on corner. Actually we have two conditions are here. One is resting on edge or resting on corner. So all the previous problems which were resting on edges, but this is the 23rd problem. In this problem we have to place the pentagonal plane on HP with the corner conditions, with the resting on corner. So and also he has mentioned the one more word or one more condition here, that's what perpendicular bisector of the edge. So perpendicular bisector, what I explained earlier, if the word mentioned in the question, I mean the perpendicular bisector or median or diagonal. So if you mention these words, so let we come to know it is a problem on beta angle problem, hence we need to determine the beta angle. Okay. So now the first condition here, the pentagonal lamina with a corner on HP, its having a sides is 25 mm which is resting on corner in a HP. So the second condition is the lamina which is inclined to HP at 30 degree, and the same lamina, I mean it's a perpendicular bisector which is inclined to VP at 45 degree. Inclined to, it's what bisector make bisector, the bisector perpendicular bisector inclined to VP at 45 degree. Now first construct the reference line with a thickness of 0.13 mm. So give the namings for that. This what X, another end is called Y. So above XY line called vertical plane and below XY line called horizontal plane. Go for first condition, that's what pentagonal plane which having edges are 25 mm which is placed on one of its corners on HP. So first as usual the method of construction, we already know the construction method of the pentagonal plane. The total sum of the angle is 360 degree, but each angle, but we require 5 sides. We require 5 sides in a pentagon, so each side should be 25 mm and angle of each side should be 72 degree. So start from a horizontal line. So the side is 25 mm initial side and angle should be 0 degree initial angle. Then I will input the second angle, that's what exterior angle of the pentagon is 72 degree, and it's what length, to make 25 mm length and angle should be 72 degree, and third side again length should be 25 mm, angle should be 72 into 2, input 72 into 2, press enter, then again length should be 25 mm, angle is 72 into 3, then again length should be 25 mm, the fourth angle is 72 into 4. So it completes the pentagon plane, the top. So now it's the what way of construction of the pentagon. So now it is in a horizontal way. So now we have to rotate this one for the corner, because the problem the pentagonal plane which is just on corner on a HP, we have to make it a corner condition. Okay, so for that go for rotate command. So now select any one edge to make it rotate. So we'll go again once again, rotate command. Select any other side. See if it is vertical indication, vertical line means the left hand side, left corner opposite of the perpendicular bisector should be exactly at the corner condition. So now just you have to move for your convenient distance. So it's the way of construction of a pentagon and rotate in a corner condition. So along with that, your perpendicular bisector. So it means we need to draw a median here. So we need to construct the median here. Thickness should be 0.13. It's what the perpendicular bisector. So give the namings for that. For each corners, I call this one as A, B, then C, fourth point is D, fifth point is E. But the median perpendicular bisector, I call this one as point M1. You can take any point, so I have taken M1 here. So it's what the true shape of the pentagonal plane with the sides of. You have to show any one sides, dimension of any one sides. It's what 25 mm. So after construct the top view of a pentagonal plane with a true shape, it is called true shape. Now construct the front view. Now construct the front shape of the same pentagonal plane. So project vertical lines from each points, from top view to front view, I mean up to the XY line. Okay. So after that, when the observer is observing the true shape of a pentagonal plane from the front view, so it look like a one line. So now we have to represent that line from each point here. Start from point A up to point B, then point D. So we have to represent that one in the form of thick. So select the whole line, select this line. So I mean it is visible, red color indication. I want to make it this one as a 0.5 mm thickness. So after that, give the namings for that. So A is the point here, A dash is a point A is a visible, and you have to express in terms of dashes for the front view points. So B and E both are in the same line. So for the front view, for the observer from the front view, B is a visible but E is a invisible. So B you have to express without bracket, whereas B dash of E is a invisible point, put in the bracket. Similarly, C dash is a visible, D is the invisible, hence put in the bracket. So this got the front view portion of the plane. So now go for the second step. What is the second condition? So we'll go for it. Its lamina inclined to HP at 30 degree. So lamina means C dash should be inclined to HP at 30 degree. So now the procedure should be same. So move the whole lamina on XY line only. So we have to make it inclination to HP at 30 degree. So it's what it's already cutted portion. Okay, I will go to once again construct this line once again. So be aware of moving or copying the moving or rotating the commands here, using the commands, because we have to cut on or move, copy or move. Be aware of that one. Thickness, make it thickness of 0.5 mm, and here okay. So A dash is called B dash of C dash, B dash of E dash, and another point C dash of D dash. C dash is a visible, whereas D dash is a invisible. Okay. Now rotate A dash, E dash. These were same length. The length should be same here. So just you have to rotate the lamina inclination to HP at 30 degree. So go for select the whole entity, go for rotate command, rotate from A dash to C dash, select the point A dash to C dash. The inclination angle should be 30 degree to HP, the position also should be 30. Now check the angle whether it is exactly 30 or not. So make it zoom and check it once again. Okay, now it is 30 degree, so it's what right. So after construct the front view, now go for construct the top view portion. So for that, project the vertical lines from front view to top view from each point. Similarly from C dash to the line should be vertical to the top views from the front view. After that, again construct the lines from each points of the true shape towards right side. So A and M1 on the same line. So drop to here. Similarly from B, similarly from C, so better to draw continuous line, later we can use trim the unnecessary lines. Okay. So now use the trim command to trim the unnecessary lines. Okay. So now construct the reduced shape or apparent shape in the top view from the front view points as well as from the horizontal plane. So go for line command. So start from the point A. So actually it is a horizontal A point, so and vertical A point, both are intersecting at here. So hence I will start the point here, both are intersecting at here. This is what point A dash. Then vertical B dash line and horizontal B. This is what the B. So we'll go for zoom area. Just here to zoom this area only. Okay. So horizontal B line and vertical B dash line both are intersecting at here. So hence it is called as B. Then horizontal C point and vertical C dash line both are meeting at here. What point C? So we will make it thickness, give the thickness of this plane 0.5 mm. Then D line and D dash both are intersecting at here. It is called D dash. Then E, and ultimately A dash, join up to A. So here the two lines make it thick. Select the both lines and give a thickness of 0.5. Okay. So after that, give the names for that. I call this one as A, for B, C, D, E, and one more, that's what M. So in the true shape, AM1 is the perpendicular bisector of the pentagonal plane, and AM is also perpendicular bisector of reduced shape. AM1 is the perpendicular bisector of the true shape. AM is the perpendicular bisector of the reduced shape. So both distances are different here. Okay, which are not same. So look at here, it's what the distance is 38.47. So we want to check this line also. But here it is a continuous line. I want to make it split. So then hence go for the split command. Go for split command. Select the element which is going to be split. Then exactly split at the point A. So now the line is splitted here. Line is splitted. It's what 33.32 and it is what 38.47. So you have to make it both lines. Note down the value. One is 38.47 and one more is 33.32. So the second stage is over. Then go for the last stage, the perpendicular bisector of the pentagonal plane which is inclined to VP at 45 degree. I mean the lamina is inclined to VP at 45 degree. So we need to determine the bisector. We need to determine the beta angle here. So go for inclination to VP. That's what 45 degree. Inclination to VP at 45 degree. Take a convenient point on the XY line. So draw a inclination angle that should be minus 45 degree to VP. Okay. So thickness should be 0.13 mm. So after construct that one, check the angle, show the inclination angle, it is what, 45 degree. Fine. So now we have to mark a point AM1 on the 45 degree line. So for that, go for arc by center point method. So before that, we have to check the length of AM1. AM1 length is shows. Actually, if you select the line AM1, obviously it shows the length of AM1 in this command here 38.47. 38.47. So now go for arc by center point command. Take any convenient point on the 45 degree line. So radius should be how much? 38.47. It's what the true perpendicular bisector length. 38.47. Just cut the arc here. So after cut the arc, then draw the locus line. So from the point M1, so it is what point A. This is what point M1. So now draw a locus line until getting the intersection point. Don't draw the line. Okay. So this is what the locus of M. So after that, now check the length of AM. Now check the length of AM. The length of AM is 33.32. So now again go for arc by center point. So to find the point A here, just keep the cursor on the arc line. So it shows the center point A. The line should be 33.32. That's what reduced shape. Perpendicular bisector of the reduced shape AM should be 33.32. Enter the value of 33.32. Then draw it here. Okay. So it's what 33.47 and it's what 33.32. Fine. So give the namings for that. I call this point as give the namings. This point was A, point A. This is what M1. What do you call this point as M? Now, in order to obtain the angle beta, so now join points AM. Now join the points AM. From the M, join up to A. And further thing, we have to use the extend command. So just you have to keep the cursor on the line. You will get the extend line. Then the obtained line you have to measure it. Use the angle between command. The obtained angle is 55 degree. The beta angle is 55 degree. So it's what's actually we required here. So now on this 55 degree line, the perpendicular bisector of the reduced shape AM should be placed here. So what do you do? So go for move command. So select the whole entity. Okay, just you have to select the point A. Just click on the point A, and you have to, it should be copy and move. Just I want point A here. So place it on the point A, and meanwhile you have to rotate the AM. So select the whole entity. To rotate at an angle of 55 degree. Go for rotate command from the point A to M. So make it zoom during rotation. just you have to place it on the point M. So now it is exactly on the inclination of 55 degree. The reduced shape, perpendicular bisector of the reduced shape AM should be placed on the 55 degree line. Now this is a whole perpendicular pentagonal plane. The whole pentagonal plane should be inclined to 55 degree. That's what angle beta. So just you have to read the unnecessary commands here. So actually it should be here. Okay. It is also not required. Just delete it. Okay. Here it has to be B here. Just you have to type B here, B, C, D and E. Okay. Keep it on the, just move upwards. Okay, fine. So after obtain the third stage, then in the top view, so again go for last stage, the front view. So draw projection lines towards upwards from the each points of the top view, from A to, then from B, then from C, then from D, then from E. Okay. So similarly project the lines towards right side from each point. So B and E on the same line here, same point. Same point, just you have to draw here. Okay. So now trim the unnecessary lines. Okay. So then go for last step to obtain the pentagonal plane. So go for line command. So thickness should be 0.5. So we'll go for zoom area command. So to make it zoom for your convenient. Okay. So now we'll start from point A. Vertical line is A here and A dash is here. Both are intersecting at here. So hence I call this one as A. Then B. This is what the B and B dash both are intersecting at here. B dash. And this is what the C line and both are intersecting at here. It's called C dash. Then D is also here. D and D dash both are meeting at here, called D dash. Then last point is vertical E line and horizontal E dash, both are intersecting at here, called E dash. And again up to the initial position, that's up to A dash. So it's what the plane, pentagonal required plane. So now give the namings for that. Start from A dash, B dash, C dash, D dash and last called E dash. So this is what the required pentagonal shape in the front view at the last stage. So it's what the pentagonal problem.